Okay, class. Today we're going to continue the next topic on theory, traffic flow theory. Okay, we want to see the parameter in traffic flow itself. So previous lecture we cover the parameter, how to collect the parameter on the traffic, such as volume, speed, delay, but delay I not do the lectures. I just put the lecture notes. You can refer that particular lecture notes, because we not going to touch detail on the delays and the gap and so on. But I provide the material. Okay, now we continue for the parameter with the traffic flow. The first one is speed. We just learn the speed itself, but now we want to look the behind theory behind the speed itself. Okay, it's the rate of motion as distance per unit time, generally mile or kilometer per hour. Okay, we have divided speed into two categories. The first one is space mean speed. Okay, space mean speed, which we look at the space itself. This one we can see the animation to represent what kind of space speed means. Space means speed, is it? Okay, we do the distance. This one we represent as a space. We put the distance to be a space for collect speed for that particular vehicles. So we have distance of 1 kilometer and time taken. We start to clock in and clock out for individual vehicle. Then we can determine average speed for that particular area or study location. So we obtain 55.4. So here we have a formula Vs. S represents a space. Vs, which is space mean speed, n is number of sample, L is length of segment that we determine to be a reference section, and then summation of time individual vehicles. Okay, next we have time mean speed. Okay, previous space mean speed refer to length of the section, that particular activity. This one is time mean speed, okay, which is we represent as T, summation of V individual divided by number of vehicle that we collected. So we can see these animations. So this is actually the spot speed, the spot speed data. So we're going to have one spot or one single station to record the speed for an individual vehicle. Then from there we get the average, average for the sample numbers. In this case we have 3 sample number, so we obtain 60 km per hour for average speed. Okay, next there is a relationship between two mean speed. This mean speed. First we have Vt, which is time mean speed. So it relates with the space mean speed plus sigma square and divided by space mean speed. Or we can inverse. We can inverse this relationship if we put Vs as reference. So we have a relation to Vt with time mean speed. So we have deduct or we have minus. This one, if you use Vt, they have plus. If you want to determine Vs, we have minus, sigma square and Vt. So everything here refer to T because we want to determine Vs. Here we want to determine Vt, so everything here we refer to S. So to determine Vt, sigma square T, we have to use other extension formula. So summation between individual speed deduct with the Vt we determine from here. Okay, then we can apply here. Okay, this is example. Okay, just read the example. 3 vehicles pass a kilometer post at 60 km per hour. The speed itself, 75 and 54 km per hour respectively. what is the time mean speed of these three vehicles, and also find approximate space mean speed. Okay, we're going to determine or calculate two speed, both. Okay, what to do? The first one is quite simple, very straightforward. Okay, we want to determine Vt, which is time and speed. We just obtain three sample and divided by the number of sample. So individual speed and divided by number of sample. So we can obtain 63 km per hour. Okay, next, to determine space mean speed, we know space mean speed, we have to determine Vt, because in space mean speed, this one, we have to determine this one, sigma square t. So here, we have to determine sigma square t, because we already obtained Vt. So Vt here, Vt. So here, Vi, V individual. So we do the summation, all individual speed, deduct by average speed from Vt. So divided by 3, so we obtain 78 km per hour for sigma square. So here the value represents sigma square, no need to square anymore, because this value we already square. Okay, Vs, we know Vs is Vt deduct by sigma square divided by Vt. So here you just insert the value. Now we obtain Vs is 61.8 km per hour. So very straightforward and easy to understand. The next parameter we have volume. So volume is actual number of vehicles observed or predicted to be passing at point during a given time intervals. So it could be from the vehicle and also from the pedestrians, because volume represent two categories, whether vehicle or pedestrians. But we given a given time interval to record their activity. Might be from 5 minutes, 10 minutes, 15 minutes, or half an hour for activity for interval. Okay, flow rate represent the number of vehicles passing a point during interval less an hour, but express equivalent to hourly rate. So we're going to convert from the volume that we collect or observe, even less than 1 hour. Let's say we taken the data for 10 minutes or 15 minutes. We just multiply to convert into hours. This one, example, 200 vehicle observed in 10 minutes. So within a 10 minutes, so we multiply by conversion 10 minutes to be hour. Then we can estimate the rate of flow rate to be 1,200 vehicle per hours. Okay, net density. Density is number of vehicle occupying given length of the lane or roadway average over time. So kita nak lihat kepadatan kenderaan pada jarak section di sesuatu laluan ataupun lebuh raya ataupun highway. Okay, express vehicle in kilometer. So we're going to observe 1 kilometer, 1 kilometer numbers of vehicle. We can segmented to be less than 1 kilometer, but you have to consider to multiply to be 1 kilometer. Okay, density can be measured directly from area photo. This one, they give example from area photo. You can use now drone, simple to operate drone, and capture the scene of the traffic at any locations. From there, you can calculate it manually to determine density of vehicle. Or we can manipulate from basic formula, which is from K, here we have K, but the basic formula for Q or flow itself, Q equal V multiplied by K. Okay, these are the basic formula to determine flow. From there, we can manipulate K equal to V over Q over V. Then we can determine the density if we don't have this particular area photo. Okay, now we how to remove this pen. Okay, now we look at this simple question. What is the density of southbound traffic on this highway? Excuse me. Okay. We have a length section of 500 meter. So now we can count. We can count individual vehicle to this particular section. So from here we obtain 14 vehicles. 14 vehicles within 500 meter or 0.5 kilometer. So we have to double. Because the density consider unit vehicle per kilometers. Total vehicle per kilometer within 1 kilometer. This one we put observation for 500. Dia kena multiply by 2 lah. Dapat 28. 28 vehicle per kilometer. Now we move to other parameter, which is spacing. It's defined as distance between successive vehicles in traffic streams as measured from bumper to from bumper. So it means we're going to determine the distance from two vehicles. So back vehicle, front vehicle, but the point to reference is from bumper to front bumper. Maksudnya bahagian depan kereta ke bahagian depan kereta. Itulah jarak dia. Nanti saya akan tunjuk illustration. Okay, next, headway is corresponding time between successive vehicle as they pass point on roadway. So ni pun bukan sama juga, tapi ini kita measure tentang times. Ini distance. Distance we can represent meter, time we represent second. Okay, next, clearance. Clearance is defined distance between successive vehicle traffic measure from front bumper to back bumper. This one differ from the spacing. Spacing we measure from front bumper to front bumper. But for clearance, front bumper to back bumper. So different. Gap, okay, corresponding time between successive vehicle, they pass a point of roadway. So dia lebih kurang macam headway juga tadi. Tapi dia tak sama dari segi kedudukan untuk measure daripada kenderaan depan dan kenderaan belakang. So kita akan lihat ilustrasi. Inilah lebih mudah faham. So kita ada clearance, spacing dulu tadi. Spacing from bumper to front bumper. So spacing, kita ada spacing dalam meter. Headway from bumper to front bumper digunakan unit second. Okay, gap atau clearance from bumper to back bumper. So measure in meter. The gap also from bumper to back bumper, but measure in distance in second. So here we have a relationship to determine the gap and clearance. So here we have G represent gap equal to H headway. Okay, minus L is the length of vehicles. Okay, average length, and also the V, which mean speed. Okay, also they have other relationship to determine between spacing, headway, relate to speed, flow, and density. So here we have average density can be determined by having average spacing, because spacing in unit second, meter per vehicle, so we have to convert to be kilometer, therefore they have 1000 conversion from meter to kilometer. Okay, next we have a headway equal to average spacing and average speed. This one, spacing we have already the measurement, meter per vehicle, but the speed somehow we have kilometer per hour. Then we also sometimes we need to convert. But if the question given rate from the rate itself meter per second is okay, you can use directly. Okay, next flow rate equal to 3600. This one the conversion, because the headway itself is second, so the flow itself is hours. So that's why you see here the extra number 3600. This means conversion. Okay, next, land occupancy. Land occupancy can be described as a ratio of the time that vehicle are present at detection station in traffic lane compared to time of sampling. So we're going to observe and determine numbers vehicle that we detect for that such particular location that we install the detector. Then the observed activity, the time itself. Then we will know the lane occupancy. But normally we can multiply by 100% to represent in terms of percentage. So we have very straightforward formula. Summation of T naught, which is individual time taken from that detector, divided by total time observation. So we can also determine by this formula, T naught from L plus C Vs, if we got the speed for that particular vehicles. Okay, then we can also determine density using this extension from lane occupancy by multiply by 1000. So divided by L plus C. C is average length, vehicle length, and also C is the loop distance from detector. So you can remember the method of measurement to collect the volume or speed. We have a loop tube pneumatic to be detector. Okay, now we can also determine the lane occupancy as R. So we can also consider this method, length of vehicle submission, length of roadway session. Okay, let's take a look of this particular example. Okay, during a 60-second period, so the time is very short because the detector is quite sensitive and can detect very fast. The detector occupied by vehicle for following times. So there is about 5 activity that detected from the particular detector from the vehicle. 0.34, 0.38, 0.4, 0.32, and 0.52 seconds. Okay, first determine the lane occupancy and estimate the value of Q, which is flow, K density, and V speed. Okay, assume loop detector length is 3 meter and average vehicle length is 8 feet. Okay, here they put the distance of loop. Okay, let's say we have a road here. So sorry, my sketch is not really sharp. Okay, you can put here as a reference for detector. Go here, they put distance as 3 meter. Okay. Okay, here they have a loop. Okay, loop like that lah. Jadi kenderaan lalu ni akan detect lah kan. So 3 meter dia buat. Okay, average vehicle is 8 feet. The length of vehicle. Okay, the solution. The first one, lane occupancy. Remember, lane occupancy equal to summation of T naught divided by T. So first we have to determine T naught, summation of T naught. Okay, we just add all the value from here. The time taken to detect the vehicle past this detector. Okay, 1.69 seconds. Okay, the total observation number is 60 seconds. So we can obtain the lane occupancy. Okay, 1.69 divided 60. Okay, multiply by 100% because we want to put value in percent. If you don't want to use percent, you can use the decimal value lah. Okay, next, to determine flow, density, and V. Okay, we start with density because we already got or obtained the value of lane occupancy. This one is lane occupancy, LO. Okay, we remember the formula of lane occupancy. LO multiply by 1000. Okay, divided by length of vehicle plus C, which is loop detector. Okay, remember this one. Okay, you have now 2.44, whereas they give the length of vehicle is 8 feet. Length vehicle is 8 feet. So you have to convert this one into meters. So you have to multiply with the conversion value. 0.3048. Then we obtain 2.44 meter. Okay. Now we get the answer is 6 vehicle per kilometer. So very less, because the scenario for this particular area, the traffic is very, very low. That's why the density is considered small or little value. Okay, next, to determine speed. So remember, we have this formula to determine V S, or space mean speed, n equal n bracket by L plus C. So L we obtained already, and C already we have, and summation of T time we also determine. So we insert all this together, then we obtain 13.88 meters per second. So we convert into kilometer per hour for speed unit. Okay, next we can determine flow. So flow, as I mentioned before, we have this formula. So please remember this formula, and this is quite basic formula. So you have to consider as do memorize this one. Like formula for pressure, sigma over P over A. So this one is very typical formula. Similar like this one. Flow equal to Vk. So please remember the formula. The very basic formula you have to remember again and again. Okay, we obtain V. So we obtain K. So now we got the flow for this particular area is 300 vehicle per hour. Okay. Can you follow my example calculation here? Can you follow this one?
Yes, sir.
Okay, now we move to this particular scenario. So we have two category of traffic flow. Uninterrupted traffic flow occurs on facility that have no fixed elements such as traffic signal or stop signs external to traffic streams. This means the element itself will be reflect the flow of the traffic itself. So not the presence of the traffic flow. Okay, we can see this particular slide to look at the scenario. So this one is uninterrupted flow. So this both sides consider uninterrupted flow because they don't have any fixed system or facilities to disrupt this flow. Even this one quite heavy flow, but this one is less flow. But both are considered as uninterrupted flow. Okay, next we have interrupted flow. Occur on facility that have fixed element causing periodic interrupt flow to the flow. So traffic stop and significant slow down periodically are irrespective of the how much traffic exists. So there is a situation here. Okay, please don't focus on this one, but focus on the upper roadways one. Okay, you notice that one, the flow itself is going to disrupt or to have a stop and move. So this could be the presence of the fixed element of the system that interrupt this flow. Okay, next we're going to have some activity on Kahoot. So please get ready your handphone or your computer. We're going to start Yahoo activity. Okay, good. We have covered this activity using a Kahoot IT. Congratulate those who winner. Okay, now we move to explanation. Okay, the left picture is represent for uninterrupted flow, whereas for right picture represent interrupted flow. Why this actually? Okay, don't get full with the lot of the traffic here. So the traffic not represent the flow to represent uninterrupted. As long the facilities is designed for uninterrupted flow, this is uninterrupted flow. Aliran tidak terganggu. Whereas this picture, we notice that less traffic, but the flow of the traffic is disturbed by this kind of the elements, such as traffic signal, intersections, or many other things, facilities, that interrupt the flow itself. So do not fool, don't get fooled by the picture. Okay, let's see what kind of the facilities that have uninterrupted flow. Okay, in freeway segment or freeway section, multi-lane highways and two-lane highways. So normally they provide uninterrupted flow, aliran tidak terganggu. Okay, whereas for interrupted flow, we have flow that occur on this particular facilities, at signalized streets, unsignalized stop signs, arterial is urban highway or urban road, banyak persimpangan kan, jadi gangguan lah, laluan terganggu. So then we have a transits for the bus, for the trams, pedestrian walkway kan, kena berhentilah kenderaan tu sebab ada pedestrian lalu, bicycle path. Okay, not uninterrupted flow and interrupted flow are not term described facility that describe facility, not the quality of flow. Please remember that. It's describe the facility, not the quality of flow. Okay, now we're going to detail on the theory for uninterrupted flow. So this is the model. So we have here the trend or the pattern activity for, let's say, for vehicle C, D, B, and A. So here at this level, the speed of vehicle is free flow speed, and in terms of the flow, it's quite low but still under the uninterrupted flow. Then they can reach at this maximum flow qualities. This just some example. Put the value, not the ultimate value, but just example. Okay, under this dotted line, we consider normal flow. So which is reached from the high to low, but consider this one is maximum, or optimal flow. But under the forced flow, which is not stable flow, so they're going to slowly the force of the flow increase. The flow itself represent like a congestion issue, and the speed tend to be very slow. Okay, you can read this explanation to understand the phenomena or the situation. Okay, also we have this another relationship to understand between this parameter, speed, flow, and density. So if you have speed and density, so the behavior of the two relations to be linear relationship, like y at plus a lah. Cuma kat sini dia punya gradient dia minus sebab invert kan, dia punya keceruan dia invert Kalau y m at campur c tu dia macam ni yang ni dia invert sebab dia semakin tinggi speed, density memang rendah dan kurang. Tapi semakin tinggi density, speed akan terjejas dan makin rendah hingga tak ada speed jam tu sah. Okay, in terms of speed and flow, so we have this pattern. That this pattern, this pattern. So this pattern is not simply like this kind of the graph. They have a lot of the data to be plot to get this pattern. Jadi banyak data yang akan collect dan tengok dia punya plot yang possible lah kan. Jadi dia akan plot possible curve macam ni lah. Jadi pada flow yang maximum, which is under this one, so speed from free flow into optimal speed. This one is free flow speed, this one no speed. This one is optimal speed from optimum flow. So this one, flow and density. At the optimal flow, they have half of the density value. So here, optimal flow provide half or V optimal from the free flow speed. This one, from maximum or optimal flow, they have optimal value for density. So this one consider jam density. No moving vehicle at all. This one is considered the optimal one. Okay, these are the function to represent the relationship between speed and distance, speed and density. Okay, we have here we add where free flow speed or free mean speed. This one is kj, which is mean jam density. So at this particular region, we can determine the relationship to determine V, which is VQK, and V over Q, K and Q. No, VQK, QV, V, Q over K. Q over K. Okay, here we have a region that can we determine the point of V Q from the area of region. This one for the K. So the basic one is consider Q for this particular formula. We have start with this formula. Q equal to V K. So we can manipulate this formula. Okay. Okay, relationship between this one. So when density is 0, which is K0, we refer here, when K0, okay, the speed is free flow. The speed is free flow. The free flow speed bukan nak kata maximum not the optimum but free flow. Free flow speed. Okay, when 0 speed, which is here, so we have jam density. So density is considered jam. Okay, then here from flow and density relationship. So we have here, we have looked before this one. At Q maximum or Q optimum, Q maximum here. So we have K optimum or K maximum. Kj, this is not maximum. This one is totally no flow and jam vehicle Q. So we're talking about the stable of flow. So the ideal one or the maximum could be for the density at this particular point when Q is maximum. So here we have a consider region of uncongested stable. By this one they have congested and unstable flow, which is forced flow. So here we can manipulate to determine Q using this particular this one using this particular function. Just insert this one into this particular basic equation. Okay, here also we can determine when Q maximum or Q optimum. So we have maximum in terms of the speed or optimum speed. So free flow is not represent in terms of ideal speed for the flow itself. But here we can start with free flow to be no flow at all. Because this one starting as the free flow speed. Okay, here we have uncongested and stable flow, but here we have congested and unstable flow. Okay, capacity maximum, the maximum flow of facilities that are just shown in that particular graph. That we can look at region of unstable flow, which is high density and low speed, in a region of uncongested and stable flow, which is low density and high speed. Okay, these are the relationship. We're going to determine how they obtain this one. This particular graph, VM and AM. So using what we call persamaan perbezaan, differential equations. So we can substitute this value. We know V equal to Vk, Q equal to Vk. I just show in this particular formula. So always remember this formula. Okay, Q equal to Vk. So we substitute V here value, and we do the operational of differential equations. Operational. Then we obtain the Vm. So to be half of Vf. So similar method to determine the optimum density. From here we just substitute the K to represent the equations. So we do the operational for the differential equations. Now we obtain the Kj half to represent Km, which means density for optimum or maximum. So from there we can determine Q max, which is still represent Vk, which is Vm now, Km now to represent Q maximum. Or we can also use others option, which is Vf multiplied by Kj but half. Also this got the similar value. So now we have two formula. This one, first one, or this one. You can use either one. Okay, now we move into this particular exercise. Okay, just read this question. A traffic streams is moving at steady state when entering mountain grade. Upon entering the grade, the speed, density, and the flow are 72 km per hour. This for speed. 25 vehicle per kilometer. This for density. And the flow is 1,800 respectively. Okay, we have these three parameter value. Okay, on the grade, a truck drop speed of 15 km per hour, causing traffic bunch up to a density of 85 vehicle per kilometer. So there is a next scenario. The truck climb the hilly road and drop the speed because very heavy. And suddenly the traffic back or rear will be Q with a long Q represent up to 85 vehicle per kilometer, which is density. Okay, when the truck is pulled over, traffic accelerate to the maximum flow and until steady state flow condition is resumed. So back to normal, but little bit differ from previous. Okay, the first calculate the flow of the traffic behind the truck on the mountain grade. B, jam density and free flow speed. C, density and speed when traffic resume a steady state flow. And the last one, maximum flow. Okay, from the previous theory and formula, now we can solve this question or the scenario. Okay, let illustrate this one. Okay, at the first scenario, so they have a traffic having Q or flow as 1,800 with the average speed 72 and density of 25 vehicle per kilometer. Okay, then when the truck is climbing the mountain or the hilly road, okay, the speed drop into 15 km per hour and the Q itself is increased up to 85 vehicle per kilometers. So now what is the flow for this scenario? Supposed to be the flow going to be low or up? What your assumption? Low or up? You don't know, Okay, this is very straightforward. This is very straightforward, Okay, use this formula. Q equal to Vk. So we have now 15 multiply 85. So we now got the flow is low because the speed is less, increase the capacity. So the flow itself is low lah. Sebab dia banyak Q kan, macam mana bergerak. The flow tu dia pergerakan kan, aliran. So the aliran itself is low lah. Maksudnya kuantiti aliran tu makin menurun lah sebabkan Q yang panjang dan low speed. That's why you obtain low Q. Okay, next B to determine what B? To determine what? Jam density and free flow speed. Okay. Okay, we have these two scenario, which is speed and density. Okay, now we want to manipulate to obtain the equation to determine free flow speed and jam density. So this one we try to manipulate to get the gradient, keturunan dia kan, gradient, the new gradient sebab kita tak ada value untuk gradient dekat sini so we have to determine gradient. So we got 2 point here. Kalau kita lukis graf ni dia adalah kan dia punya titik untuk tentukan gradient dia kan. So kalau graf macam ni kan, so kita adalah ni titik untuk tentukan gradient ni kan. Kata dekat sini masa density 1800, speed 72 dengan density 25 kan. Ni view of OK ada gerakan view of OK kan. Okay, dekat titik ni titik atas titik bawah. Now we have speed 15, speed makin rendah kan, dengan K 85. So kita tahu gradient ni berapa ni. Okay, that's why we have this kind of the solution or function. Say masuk dalam formula ni dan kita akan dapat kat sini satu nilai gradient kat sini. So nak guna apa untuk gradient ni? Nanti adalah kita guna dia. Okay, now we have this function that represent dia punya equation untuk tentukan speed kan. Okay, we know that the formula to determine V, so input of free flow speed kalau kita pergi ke basic balik nak tengok yang basic balik. Ni kan. So V kat sini determinekan oleh ni kan. Dia punya function ni. Samalah ni dia apply kat sini. Dia apply kat sini. Okay, now we have 95.75 minus 0.95K. So kalau kita transform dia ke sini, so kalau kita wakilkan dia punya value ni, so ini akan jadi VF dan ini akan jadi punya gradient kan. Macam tu Jadi from here we obtain already the free flow speed. So from this function Okay, next we want to determine the KJ. Okay, kalau kita lihat kat sini here sini ada value KJ kan. So kita keluarkan dia pergi sini. Dan ini adalah keturunan daripada sini tu gunanya untuk dapat keturunan. So from here we can determine K kan. Jadi kita manipulate lah formula ni sehingga kita dapat nilai K. So what is K? Dapat nanti nilai K dia. Here, from here Kalau tak nampak saya gunakan pointer lah. Here Ni kita manipulate lah, kita naikkan K kat atas ni, turunkan ni, jadi bahagilah 95.75 divided by 0.95, so dapat nilai ni. So this is the jam density value. Okay, next. Tak function kalau kita tak buang pointer Kita kena buang pointer ni baru boleh pergi ke next graph. Okay, given a steady flow is achieved when flow is maximum. Therefore, speed and density when state flow is achieved refer to V maximum dan K maximum ataupun optimal Okay, we obtain VF as VF tadi kan 95.75. Okay, to determine Vn, half of prefer speed. So now we obtain 47.88. Okay, km, we know km is half of kj. Jadi kita dapat nilai kj tadi 100.79. So bagi dua lah, dapat nilai km. We obtain the km is 50.4. So untuk dapat q maximum, just remember this basic formula. Always remember this basic formula. Oh no, I just go to next slide. Okay, just remember this formula. I write again. Q equal to Vk. But remember, when we want to determine maximum flow, which is Qm kan? So we have to use Qm, Vm, Km. So we have to use the reference lah. Kalau nak dapatkan Qm, semua kena Vm, Km lah. So we just obtain this one. So Q maximum equal to Vm multiplied by Km, which is 47 or 48 multiplied by 50.4. So we obtain the Q now slightly increase because the steady of the flow after traffic resume. Or you can determine also that this way if you want to get the Qm, that one, you can use Qm equal to Vf kali dengan Kj. But this one you have to divide it by 4. Okay, still similar sama je ni. You can still obtain the similar result Okay, can you follow this for the solutions for this question? Okay, so far okay You can follow this solution
Okay, doctor.
Okay, I think all the students follow the solution. Great. Okay, I think that's all for today's lessons. As synchronized session, I will stop recording these lectures, but you can still continue our class in synchronized method. I have already uploaded in Google Classroom. You can search by 12:30. Okay, I have reserved the schedule there. Okay, I will stop lecture now. You can proceed next lesson. Okay.